I want us to take a look at our exercise 15.3 homework first. Okay. Are there any problems in completing your homework? That is your question. Wait, our question here. Okay. Question 4 is homework. Question 4. Yes, there's an it. Okay. Any problems with question 4? 4? No issues. Okay. How about question 5? 5. Okay. Question 7C. Is there any 7C and 7D? No, okay, sorry. Just 5. There is not consistent with yours. Okay, so question 7E as level E. Okay. Then question 8. Question 8, okay. Question 13. 13, okay. And 14. 14, okay. So
what are the questions?
We have question 5, 8, 13 and 14. Alright then. Right, let's look at question 5. So exercise 15.3. Okay, it says that y is given to be ln x plus 1 over x plus 1, for which x is more than negative 1. Okay, we want to find the range of values of x for which y is an increasing function. Okay, so very naturally we should first differentiate, and using our quotient rule, okay, we will have x plus 1 keeping the bottom, differentiate the top, we will get 1 over x plus 1. Differentiating x plus 1 itself is L1. Okay, so naturally sometimes we may not actually write that down, it's fine. Then after that, keeping the top, differentiate the bottom over bottom square. So we simplify, x plus 1 can be cancelled out. Okay, we have 1 minus away ln x plus 1 over x plus 1 square. Okay, so this will be our dy over dx. So since the question wants us to find the yes, you want to change your votes, is it? Can you do that later? Not important right now. right? Okay. So then the question says, okay, we want to find the range of values of x for which y is an increasing function. Okay, so since y is increasing, dy over dx is more than 0. Okay, so with this being more than 0, right, we know that, okay, given this interval of x more than -1, our x plus 1 squared, in fact, regardless of whatever interval we're given, so long as x is not equals to -1, our denominator is always more than 0. Okay, so since we're given this thing that 1 minus ln x plus 1 over x plus 1 squared is positive, and the denominator we know that is always positive, so that means that our numerator itself has to be positive. Okay, so in other words, because as I mentioned before, we cannot actually do logarithm on both sides, okay, of an inequality. So when I shift this ln to the right side, I will see that 1 is more than ln x plus 1. In other words, ln x plus 1 is less than 1. Okay, then we have to rely on our graph of our ln x plus 1. And our ln x plus 1 would be a graph that looks like this. Okay. So with our y equals to ln x plus 1 looking like this, and some important points is that we are looking at it being lesser than 1. So we need to see where y equals to 1 is. And when y is equals to 1, okay, so just a side working. So when y is equals to 1, we get 1 equals to ln x plus 1. Okay, and then we solve this logarithmic function. So that means that e to the power 1 equals to x plus 1. Okay, and hence e to the power 1, or rather e itself, minus 1 is equals to x. Right? So that means over here, we are looking at e minus 1. Okay? And therefore, in this case, since we're looking at the part whereby our logarithmic graph, okay, is below your y equals to 1. Okay, and this is the part that is below. That means the range of values of x is anything from e minus 1 and below. Okay, and therefore, x itself must be less than e minus 1. Okay? And because our boundary that we are given is that x must be more than -1, e minus 1 is more than -1. Therefore, okay, our x interval will be something that's more than -1 and less than e minus 1. Okay? So the challenge is to really make sure that you know your logarithmic graph. Okay? Then after that, you can determine what is the range based on your understanding of the inequality over here. Okay, because our inequality over here means that your ln graph must be below your y equals to 1 graph, since it's less than. Questions? Okay, next we look at question 8. coordinates of the point on the curve at which the normal to the curve is parallel to 3y equals to x plus 5. Okay, so to make sure you understand the question, you can draw any curve that we want, okay, to help us understand. Okay, then after that, we want to find the coordinates of the point on the curve at which the normal, okay, so we have this tangent, and then we have a normal. Okay, and this normal is actually parallel to a line 3y equals to x plus 5. Okay, so 3y equals to x plus 5 may look like this, and they are supposed to be parallel. Okay, so what we want to find is this point over here. Okay, so in order for us to do that, we differentiate to know the gradient of the tangent first. Okay, so for differentiation, we get negative 3 over 7 minus 3x. This will be the gradient of the tangent. So the gradient of the normal will be the negative reciprocal of negative 3 over 7 minus 3x. In other words, negative 1 divided by negative 3 over 7 minus 3x. And that will give us 7 minus 3x over 3 itself. Okay? And this gradient of the normal, or rather the normal itself, is expected to be parallel to 3y equals to x plus 5. So the gradients need to be equal. So from the equation of that straight line 3y equals to x plus 5, we get that y is equals to 1 over 3x plus 5 over 3. We have to change it into y equals to mx plus c form in order for us to deduce that the gradient is 1/3. So 7 minus 3x over 5 equals to 1/3. Okay, then we cross multiply and solve. Are retiring today. Okay, so x is equals to 2. And then our y, okay, because our point is supposed to be on the curve, we have the curve equation. So we sub x equals to 2 into y equals to ln 7 minus 3 times 2. That is a ln 1 and that is 0. Therefore the coordinates will be 0. Y is a decreasing function. Actually, I don't understand why is it that the question have to say x increases, because that's not very meaningful. Okay, because that's the definition of decreasing function, right? Decreasing function means that as x increases, your y value actually decreases. Okay, so given that y equals to ln 7 minus 3x, for which we have already found our dy over dx, which is negative 3 over 7 minus 3x. We want to show that this is going to be negative. Okay, and in order to show that it's negative, it's not just because there's already a negative sign here, But we need to show that 7 minus 3x is actually going to be positive, because only when negative divide by positive, then we will get an overall negative. Okay, so given that x is less than 7 over 3, we manipulate it towards 7 minus 3x. So we first multiply by negative 3, and when we multiply by negative numbers, inequality sign flips. So negative 3x is more than your negative 7. Okay, and then we have to add 7 on both sides in order to achieve a 7 minus 3x, which means that 7 minus 3x is eventually more than 0. So because the denominator is more than 0, it is positive, and the numerator is negative, okay, we see that the overall fraction itself is going to be negative. Okay? So since negative 3 less than 0, and 7 minus 3 more than 0, then your dy over dx is less than 0. Therefore, y is a decreasing function. Okay. So that will be how we show that it is a decreasing function. Question 13. May I know what is the struggle in question 13? Part 2. Okay. So we want to express dy over dx into something, then I'll just skip question part I. Your x coordinate should be 3. Okay. For part 2, we want to show that dy over dx can be expressed as a certain form. So to differentiate, you will find that if you want to differentiate directly from the given function, it will be a tedious task. But since it is expressed in a single logarithmic form, applying our logarithm laws, we can actually split it out into two separate logarithm functions of ln 5x minus 9 minus away ln x plus 3. Okay? When we split it out like that, it will be easier for us to differentiate, okay, because we just differentiate individual log functions. Okay? Whereby we have 5 over 5x minus 9 minus away 1 over x plus 3. Okay. Then the question essentially wants it to be combined into a single fraction. Okay. So we just have to seek for the common denominator, which is the product of the two denominators. So 5 will have to be multiplied by x plus 3, and 1 must be multiplied by 5x minus 9. Okay. This is a 1, so making sure that we must have a minus 1 and then bracket 5x minus 9. Okay, very often you tend to forget the brackets, and then you just happily put 5x minus 9, which should actually in fact simplify to become 5x plus 9 in the end upon expansion. So we should be getting this answer at the end. Okay. Do I need to run through part 3? Okay. Then I shall not run through part 3, yeah? Then question given that v equals to lambda x squared ln 1 over x. In case you're not familiar with this symbol, it is not a Chinese character. Okay, it is a I think Greek letter. Okay, pronounced as lambda. Alright, spelled as this. Okay, so I think for the physics students, you might be familiar with it because we use lambda to express wavelength. Right? Okay, so find the value of x for which speed is maximum. So we need to differentiate this. We see it as a product of two things, lambda x squared with ln 1 over x. Okay, but before we jump into differentiation, it might be easier if we were to simplify this ln over here. Okay, so for this ln, it is actually ln 1 minus ln x. Okay, apply our logarithm laws. And ln 1 is none other than 0. So we are looking at 0 minus ln x. Hence, it is just a negative lambda x squared ln x. Okay. So this will be easier for us to differentiate because with this 1 over x, when we differentiate ln, we get 1 over 1 over x. And that can be complicated sometimes if our algebra skills are not that strong. Okay, so to differentiate this, we apply our product rule between these two products. Okay, so keeping the left side, differentiating ln x, we get 1 over x, followed by plus ln x. Okay, and then differentiating negative lambda x squared. Then differentiating the left side, we get negative lambda. Alright, then 2x. And this simplifies to negative lambda x minus away 2 lambda x ln x. Okay, so we need to recognize that lambda is a positive constant. That means it's just a number. Okay, you don't differentiate it at all. You recognize it like just your 2, 3, 4 and all that. Okay. Then, what you could do, if you like to, you could actually simplify this further by factorizing. So that we get this. Because in order for us to find the speed, okay, find the value of x for which the speed is maximum, that means your d over dx is equals to 0. And we're getting this to be equals to 0. So it's either negative lambda x equals to 0 or 1 plus 2 ln x equals to 0. And this solves to become x equals to 0, while this solves to give us ln x equals to negative half, and x is equals to e to the power of negative half. Okay. Right. Looking at your chapter 14 homework, which I've just returned to you, I noticed that some of you find the value of x already, okay, but then you don't actually go about proving that it is a maximum or a minimum. You need to show that it is going to give us a speed that is maximum or minimum by doing either your second derivative test or your first derivative test. Okay, but before that we need to reject x equals to 0 because the interval given for us for x is between 0 and 1. You could press into your calculator that e to the power negative half is between 0 and 1. Okay. So then, if you want to do your second derivative test, okay, then you have to do your product rule again. Okay, and your second derivative comes out to be this. Okay, then when x is equals to e to the power negative half, okay, your substitution substitution comes out to become this. Okay, whereby we get negative 2 lambda. Okay, actually in fact, for this particular question, because you do not know what is lambda, right, you cannot do your first derivative test. Correct? Because your dv over dx, you have this unknown here, you cannot find using your first derivative test. So you have no choice but to do second derivative test because it simplifies to give us negative 2 lambda. And because the question already said that lambda is actually a positive constant, so multiply with a negative number, this will have to be negative. Okay? And therefore, the speed is maximum when your x is equals to e to the power of negative half. There's no other problems, could you please submit your homework to the front? Okay, once you submit already, I want to run through some of the common mistakes I see in exercise 14.1 and 14.2. Alright, I want us to take a look at your exercise 14.1, just certain concerns that I have, okay, as I look at your working. Looking at question 3. I noticed that instead of using quotient rule, okay, we do have some people in our class who enjoys using product rule instead. Nothing wrong with doing product rule. Okay, it's about what comes after that that is important. Okay. 14.1. Okay, so question 3, most of you can differentiate perfectly fine. Okay, but it is in your part 2's answer that I have concerns in, okay, about explaining whether this curve has a stationary point or not. Okay, what some of you choose to do is that negative 7x minus 2 to the power negative 2, you equate it to 0, and then you tell me that x minus 2 to the power negative 2 equals to 0, so x minus 2 equals to 0, x equals to 2. And then you say that because the question says x cannot be equals to 2, okay, therefore there is no stationary point.
Very common.
Okay, this present itself, the way that it is being done is entirely not correct. Okay, why? Because first of all, you need to realize that negative 7, okay, negative 7 times x minus 2 to the power negative 2 is actually the same thing as this. So when you say that negative 7 times x minus 2 to the power negative 2 equals to 0, it is the same as this thing equals to 0. Okay, and then you tell me x minus 2 squared equals to 0. In the first place, your denominator cannot be equals to 0 at all. Okay, so right from the start, this entire presentation is unacceptable. Okay, to use this as a contradiction to answer the question itself. Okay, so what you should be in fact doing is that, okay, because explain whether this has a stationary point, you need to say that your x minus 2 squared is always more than 0. Okay, for all values that are not equals to 2. Then your entire dy over dx is actually going to be negative. Okay, it is going to be strictly negative, and therefore there is no stationary point. Okay, so the correct answer will be to show that it's going to be strictly negative, rather than to actually solve it this way, because right from the start, this thing cannot be equals to 0 at all. Okay. And then moving to your exercise 14.2, I noticed that your math vocabulary is not that strong. Some of you try to phrase sentences, okay, using suitable math vocabulary, but then what comes out from that sentence ends up not making much sense. Okay? So that is something that we need to work on. Okay, for example, in your exercise 14.2, question 5 part 2, the question wants to find the maximum value of s, explaining why this value is a maximum. Okay, so erase this first. Okay, first of all, to find the maximum value of s, explaining why this value is maximum, okay, we need to first find our first derivative and then subsequently equate it to be equals to 0, because we're looking for maximum or stationary point. Okay, so therefore x is equals to 2/3. And then you use your second derivative test to show that it is negative. Okay, so it is s that is maximum. when x is equal to 2/3 itself. Okay? Many of you actually also miss out in finding out what is this maximum value of s. Okay? Maximum s, not maximum x. There can never be a maximum x. This x value gives the maximum s. Okay? Because I see a lot of your phrasing in terms of how you phrase it, it is very clear that you don't know what is it that is maximum. The thing that is maximum over here is the s value, okay, whereby s is actually the area, right? So the maximum s value is 32 cm squared, okay, which is a result of this thing itself. And also, in this particular case, x and s are not points, because x and s is given to be in this context, whereby x is a certain length and s is the area itself. So some of you like to use the word that s is a maximum point, but there is no point to mention. Okay, so there shouldn't be use of that word. So do look at your own work, okay, and see what is the corrections that are written down for you. Okay, and then for question 11. Just give me a moment. Let me just open up answers. No, it's 8:59. Okay, looking at question 11, right? Some of you don't seem to know how to differentiate when there is a constant in it. So this is your question 11 part I. You get 4 pi times 48 over r plus r squared. When you differentiate this, you need to keep the 4 pi outside and then you differentiate the inside. Okay? It is just like your product rule. We keep the left side, differentiate the right side. And then we plus keeping the right side, differentiating the left side. It is just a coincidence that when you differentiate the left side, which is 4 pi, it comes out to be 0. That's why our 4 pi needs to remain outside. Okay? So this differentiation itself, okay, some of you are not getting it right. And then it affects how you find your second derivative later on. Okay, likewise, your second derivative should also have a 4 pi over here. Okay? So do take note about that, because I do see that your eventual value is not the same, hence I notice that your derivatives are not calculated correctly. Okay? And then in your question 13, the very final one, okay, some of you are not understanding the question well. Question 13 says, explain what will happen to the cost of aluminium used if the value of x were arbitrarily chosen. What does arbitrarily chosen means? It means that it's just randomly chosen. Okay, you just anyhow take an x value. Okay, that is what arbitrarily chosen means. Okay, instead of taking the value obtained in part. Okay, so in part 2 itself, you would have found that your x value is about cube root 48 or 3.63. So if you don't take this value, okay, what does it actually mean to the cost? So this x value gives us the minimum cost. This x is not the one that is minimum. It is the cost that is minimum. Okay? So if you choose any other x value, your cost is not going to be minimum. Hence your cost will actually be higher. Please specify that it is going to be higher rather than telling me it is not minimum. Because not minimum would suggest that it could either be higher or even lower. Okay, so you need to show your understanding that it is going to be higher. Right, so to be very clear rather than being ambiguous. Okay, and that is all it is for part 3. Alright? Okay, I will return to you your chapter 15.1 homework next week, okay, so that you can revise for your WA happening on Wednesday. Alright? Then, some of you have not yet also done the SLS that was posted up yesterday. Okay, Okay, so yesterday's SLS was really just some practices, okay, about what we have covered for vectors, and then also a practice on scalar multiplication of vectors. Alright, so please take a look at that and complete it by next Tuesday, please. Okay, any more homework 15.3? By the way, for Emaths, vectors is our very last chapter. After vectors, no more already. Okay, so your textbook, all the chapter 6, 7, 8, 9 is just revision topics. Okay, so after chapter 5, there's no more Emaths. Okay.